In this screencast, we're going to use Statkey to find a confidence interval. And for this one, we'll look at the difference in the average weight between people who exercise and people who don't. So here's our health data. And column B, 1 means that they've exercised in the last month, 0 means they haven't. And we'll get the weight, that's column F. And we'll copy those so we can isolate just those two and put them in their own spreadsheet. If we go to Statkey and look at descriptive statistics for one quantitative and one categorical variable, we can summarize this. I've put this in ahead of time. And if all I wanted was the confidence interval, I could skip this step, but I just want to investigate it a little first. And we see that there were 767 people who had said they'd exercised in the last month, and 233 people who said that they had not. And the average weight of those who had exercised was 168 pounds, and the average of those who had not exercised in the last month was 172 pounds. So the exercisers do weigh a little less in our sample by almost 4 pounds, a little more than 3.5, but that's just a sample. So the whole point of confidence intervals is to say, okay, amongst all people in the United States, all adults in the United States, what's the average difference in the weight between those who had exercised and those who have not? And remember, to find a confidence interval, we take the statistic and we add and subtract 2 times the standard error. So the statistic is just what we find in our sample, and the standard error tells us how much we might expect that difference to vary as if we looked at other samples from the same data set, from the same population. So to get there, we copy our 2 columns, one with the quantitative variable, whether or not they'd exercised, and one with the weight. So we copy those. Then we go to Statkey, and we choose confidence interval for the difference in means. So that's what we're interested in. And then we edit the data and put in our data. Scroll up, make sure it came in right. Looks like an extra 1 got stuck in there, an L or something. Okay. And hit OK. And x1, the mean from the first sample minus the mean from the second sample, is negative 3.73. Which is which? Well, we already know that the people who had exercised way less, and we also remember that there were 767 of them. So sample 1 here are the exercisers. And this difference tells us that the exercisers in our sample, the average of the exercisers was 3.7 pounds below that of the non-exercisers. So here, that difference is negative 3.73. And then we have to estimate the standard error. And the way we estimate the standard error is that we get a bunch of bootstrap samples from the original. So what's a bootstrap sample? Well, the computer goes in and collects 767 numbers from the original data set of exercisers by repeated sampling. So it goes in, picks a value, puts it back, goes in, picks a value. So there can be repeats in each of these bootstrap samples. And it does the same thing for the non-exercisers and then looks at the difference in means. This gives us an idea of what the difference in means will look like, how much they might vary if we had a different sample of 767 exercisers and 233 non-exercisers. So we're sort of simulating doing this, getting the same original sample, simulating doing it many, many times. So let's just generate 1,000 samples, and we see that we get a standard error of about 3.3. We'll just round it to 3.3. So that we expect that if we looked at a different sample of 767 exercisers and 233 non-exercisers, then the difference in their means, their averages in those 2 samples will be different from this negative 3.73, and on average that difference will be itself about 3.3 pounds. So that's our standard error, our estimate for the standard error, 3.3 pounds. So that's what goes in here. And then we just pull out our calculator. Negative 3.73 minus 3.3 is negative 7.03. And if we add negative 3.3, oops, I forgot the 2 times the standard error. Let's not forget that. So let's do that calculation again. Negative 3.73 minus 2 times 3.3 is negative 10.33. And negative 3.73 plus 2 times 3.3 is positive 2.87. So we can be 95% confident that the difference between the average weight of all exercisers and the average of all non-exercisers is between negative 10.33 to positive 2.87. And what is that negative telling us? Negative is telling us that the exercisers might be as much as 10 1/3 pounds below that of the non-exercisers, but it's also, the other end tells us that the exercisers might actually weigh more than the non-exercisers by 2.87 pounds. So it's a fairly wide range because there's quite a bit of variation. And so here is our confidence interval, and then just back to the dot plot. So just a quick reminder, each one of these dots, so for this particular bootstrap sample, the difference between the two sample means was 0.24. So each dot represents a simulated new sampling from the original population with 1,000 people, 767 of whom are exercisers and 233 are non-exercisers. So summary, you get the sample statistic. So what was the mean for our sample of exercisers? What was the mean for the sample of non-exercisers? In this case, we subtract them, and that's our statistic, the difference in those two means. Then by using bootstrap sampling, you estimate the standard error and simply add and subtract 2 times that standard error.